Oftentimes in chemistry there comes a need to convert something in order for it to better fit a particular circumstance. This can mean doing a simple metric-to-metric conversion to make our numbers more manageable and user-friendly, such as converting 153,000 milliliters to 153 liters. Or it could mean doing complex multiple conversions so two measurements can be compared, such as converting 30 miles per gallon into kilometers per liter. One of the most common uses of conversions is taking a measurement in English units and converting it into metric units, or vice versa. Examples of this would be converting inches into centimeters or liters to ounces. The key to solving these problems is knowing the conversion factor that applies to the situation. Here are a couple examples of conversion factors. It is common for someone unfamiliar to these types of problems to question the way conversions accomplish its task. It may appear to them to be changing the length or other value. These conversion factors are simply an equivalent value using a different unit. Let's measure this line in inches using a ruler. We find that the line is 1 inch in length. Now let's measure the same line using centimeters. We find that the line that is 1 inch long can also be described as being 2.54 centimeters long. With this knowledge, we can clearly say that 1 inch equals 2.54 centimeters. To show the meaning of this mathematically, let's look at the statement. 1 inch equals 2.54 centimeters. We can take this statement and divide each side by 1 inch. Once we simplify this, we get 1 equals 2.54 centimeters per 1 inch. Or if we were to divide each side by 2.54 centimeters, it would result in a fraction. 1 inch per 2.54 centimeters equals 1. This shows that conversion factors are ratios of two equal values with different units that are equal to 1. We'll use this in our problem to convert inches into centimeters without changing the true length of our measurement. If all we have is a ruler that has English units, we have no choice but to use the equipment we are given. So let's say we measure something to be 5.75 inches. As most scientists throughout the world do, we would report our data using metric units. In this case, let's convert inches into centimeters. We would find the correct conversion factor and write down our problem. So for our problem, what order does our conversion factor need to be in order to get our desired units? Feel free to pause the video and think about the question. These are two ways we can write our conversion calculations. The correct way to set up this problem is to put inches on the bottom so that they cancel and leave us with centimeters. We would continue to solve and get 14.6 centimeters as our final answer. It's important to know that our units don't simply vanish but are divided by its equal value. It helps to look at all values as magnitude times 1 unit. For our problem, we started with the magnitude 5.75, so we would multiply that by our units, inches. If we set up our entire problem like this, we can see exactly how the units cancel. 1 inch over 1 inch will truly cancel out, leaving only the magnitude to be multiplied and divided. Let's try one of these multi-step conversions that are a little bit more challenging. If we were to try and convert 45 miles per hour to kilometers per hour, we must take notice that there is a component of the unit that remains the same. The unit of time, hours, should remain the same throughout the conversion. Since we are not given the direct conversion of miles to kilometers, we must go through a couple of conversions using what we are given, making sure to arrange our unit factors so that they are canceling the correct units. Pause the video and give this problem a try. The best place to start is to look at all the conversion factors that are given and visualize the path we will be taking. Sometimes it helps to use both ends of the equation to determine our steps. Looking at the beginning, what conversion factor can we use to get us started? Since we're starting with miles, it would be smart to try converting miles to yards. Now looking at the other end of the problem, we see our final answer will be in kilometers. Looking at our chart, we can find conversion factor to convert meters to kilometers. Our missing link is the link between yards and meters, and if we look at our conversion table, we find just that. Looking at the big picture, it appears we must go down the path of converting miles to yards to meters to kilometers. Now comes the time to make sure all the correct units cancel out. Starting at the left, we see that miles are in the numerator spot, so in our first unit factor, we should have miles in the denominator spot, so that they cancel and leave us with yards per 1 hour. Since we know 1,760 yards are in 1 mile, 1,760 yards will be in the numerator spot. We repeat the same step for meters and kilometers and end up with this. A good way of thinking through the calculations is to multiply everything in the numerator spot and divide everything in the denominator spot. Doing this should give you 72 kilometers per 1 hour. Our next problem will be one that consists of having to convert two components of the unit all in the same conversion equation. Sam is looking to buy a car with good gas mileage. She heard that the Canadian car company Zen makes a car that gets 30 kilometers per liter of gas, but is not sure how it would compare to her friend's Geo Metro that gets 43 miles per gallon. Since she skipped chemistry class to look for cars, she didn't know how to convert kilometers per liter to miles per gallon, so she simply went with the Geo. Did Sam make the best choice for fuel-efficient cars? Try to pause the video and solve this problem. Let's start with converting kilometers into the desired unit of distance, miles. This is exactly like our previous example, except the reverse order. This time our path is kilometers to meters to yards to miles. We must arrange our unit factors in a way that we can cancel out unwanted units. We go on to convert kilometers to meters, meters to yards, and yards to miles. Now we have the miles solved for, we can move on to our volume component of our answer. This can be done in 2 steps, going from liters to quarts and then to gallons. Once you have each component accounted for, you can solve for this by using the same technique as before, giving you an answer of 70 miles per gallon, which is much better gas mileage than the Geo. It looks like Sam made the wrong choice. That's what she gets for skipping chem class.